Good morning, Top. Okay, so what date is today? Today is 31st, right? Good morning, Pokpong. Pokpong, you're not
Morning, teacher.
today? Okay, so let's wait for your friends to join in and then we can start taking the attendance, okay? Please get your science book. Pokpong and Top, please get your science book. So today we're going to review chapter 7, okay? Now chapter 6, which is about heat. We're going to review only the topics that we have learned after midterm, okay? So these will be the questions that will come in your final exams. The topics. Let me wait for your friends. Kankawi. Kankawi is not. I thought Kankawi is. Okay. Good morning, Kankawi. So you guys have science class, okay? Please get your science book. Let's wait. Because how many students are there in this class? 24 of you guys. Okay, so let's not waste time. I'll start checking the attendance. If you're present, please say I'm present or I'm here, okay? Let's first start with Khan. Oh, you are Khan. Okay. Khan, C. Is C here? Okay, best. You're best. Okay. Top. Top is here, right? Top, are you sleeping? Okay. Cao Kong. Cao Kong online. Is Cao Kong online? No. Right. All right. Prim. Absent, Prim. Krawan. Krawan. I don't see Krawan here as well. Okay. Mutta. No, right? Ja. Is Ja here? Ja. No. View. Pam. Is Pam here today? All right. Pokpong. Pokpong is present. Im. Te. All right. Panya. Panya is not here. Okay, absent. Kan. There's two Kan here, right?
Listen.
All right.
Yes.
Noi. Absent. Shompu. Present. Ingfar. Absent. Tawan. No, right? Okay, guide. Kahom. I saw Kahom.
Yes, I'm here.
Okay, Kahom. All right, so this is it. Have I missed anyone's name here? I've called everyone's name, right? How about you? Did I call your name? Guide, right? Okay. Have I missed anyone online? All right. So I'm gonna save this. So let's get started. So teacher is going to review chapter 6, which is about heat, okay? So from chapter 6, heat, right? Teacher is going to review the topics that we have learned from midterm onward, because from these topics, right, the questions for your final exams are going to be from the topics that we learned after midterm. So I'm going to review only the ones that we learned after midterm, okay? I'm going to share my screen. So teacher is going to ask you a question. Please listen attentively, okay? Okay, chapter 6, heat, right? So we're going to start from the effects of heat on matters. So let's get started with the expansion and contraction. Do you guys remember this word, expansion and contraction, from our last class? What's the word expansion here? Okay, I will give you two options, okay? Two options, choose one. Expansion means, is it increase in size when they get heated, or is it decrease in size when they are cooled? So which one is it? Which one is the correct answer? Yes, Kahom?
When heat is on.
Okay, increase in size when it's heated is called as expansion, right? Very good. How about contraction? How about contraction? You said increase in size when heated is called as expansion, right? How about the word contraction here? Contraction will be the decrease in size when the objects are cooled, known as contraction. Okay, very good. Okay, everyone, the word expansion means increasing in size when the object are hot or when we heat the objects, okay? And the word contraction means decrease in size when they are cooled, is known as contraction. Understood? Understand online, on-site students?
Understand, sir.
All right, Mutta, very good. Thank you for responding. Next one is the word vigorously. Okay, this word vigorously means with the force and energy. When you do something, you do it with the force and energy. We call it vigorously. Okay, something that is doing with the force and energy is called as vigorously. Remember these three words, okay? So let's see. I'm gonna ask you guys a question. Listen here, okay? Most matter expands when it's heated and contract when it's cool. So the example here is thin glass cracking when a hot water is poured onto it. So is this an example of expansion or contraction? A thin glass cracking when a hot water is poured onto it. On-site student, is it expansion or contraction? Yes?
Contraction.
Thin glass cracks when the hot water. Yes, expansion. Okay, it's expansion. Very good. It's expansion. Okay, because the hot water is added here, right? Pouring the hot water. So when hot water is poured, what happened to the molecules inside the solid objects inside this glass? It tends to expand, right? So this is expansion. So our main focus will be on expansion in solid, liquid, and gas. We're not going to look at contractions, okay? Only focus on expansion for the revision. So let's first look at expansion in solid when it's heated. So you know what are solid, right? What are liquid and what are gas, right? Solid, liquid, and gas. You know these three, right? So let's first look at expansion in solid when it's heated. Okay, when the heat is added here. So these are the arrangements of particles or the molecules or atoms inside the cooled objects. Okay, and these are the molecules inside the hot object. So let's see. The atoms or the molecules in the solid vibrates, okay, at all temperature. So as the temperature increases from cooled, when we add the heat, okay, when the temperature increases from the cold to hot, what happens? The atom vibrates vigorously. So what does the word vigorously mean? I just said this, right? What does the word vigorously mean? Does it mean slow? Does it mean with energy? What is it? Mutta, what is it? Answer. What's the answer? Kankawi, what's the
Yes,
answer?
teacher.
What does the word vigorously means? Teacher just explained to you, right?
Yeah.
I will give you two options. Okay. Is it mean like with energy, or is it means without energy? The word vigorously means.
With energy.
Yes, with energy, right? The word vigorously means with energy, okay, with energy. So as the temperature increases here, the atoms inside the solid, okay, they tend to vibrate more vigorously, more fastly, okay, with energy. So this pushes, since they are moving vigorously, right? This pushes the atom even further and the sizes of the molecules increases. Understood? Understand? On site? Students, are you sleepy?
Yes, teacher.
All right, very good. So now let's go to the next one. First, we have looked into the expansion in solid, right? Now let's look at expansion in liquid when it's heated. Okay. So inside the liquid, okay, when a liquid is heated, the molecules inside, this is how the molecules inside the cold looks like, right? Inside the liquid. So when the liquid is heated, the molecule of the liquid have more energy and moves more vigorously here. Okay, so this is from cold to hot. When it's heated, this allows the molecules inside the liquid to have more freedom to move. Okay, can you see the spaces here? Right, spaces in between the molecules. Before, inside the cold liquid, right, the molecules are packed together, right? Whereas when we heat them, what happens? They tend to have more space to move, right? Understood? Teacher is going to ask you a question later after explaining this. Okay, and solid, liquid, and gas. Now let's look at the gases. Do you get it, everyone? You can go to washroom and come back. Go to washroom. So are we not allowed to turn on the AC? Teacher not allowed to turn on the AC? AC may die. Cannot turn on the AC? It's hot, right? Yes, teacher. Cannot, right? No, that's why. Okay. So we cannot turn on the AC. You guys are feeling hot here, right? Okay. So now we are done with expansion in liquid. Now let's look at expansion in gases. Okay. Expansion in gases when it's heated. The molecules of the gas are far apart compared to the molecules in liquid and solid, right? You already know this. The gas molecules move at higher speeds in all directions. So let's see. When we heat the gas, let's see what happens to the gas. Okay, so when we heat the gas, the molecules also become energetic here. It moves faster and further apart when it's heated. Okay, so the volume of the gas also increases and it also expands. Understood? Expansion in solid, expansion in liquid, and expansion in gas when all of them are heated. So when they are heated, they tend to have more energy, right? Understood? They tend to have more energy. They tend to have more space. The volume also increases and expands. Understand? So, okay, I will ask someone question here. Okay, so let me ask this question to someone. Okay. Okay, let's talk about expansion in liquid when it's heated. So, what happened to the molecules inside the liquid when it's heated? Kankawi. What happens to the molecules inside the liquid when it's heated? Before they are packed together, right? The molecules are packed together. But when we heat, what happened to the molecules here? Yes, Kankavi.
Can you repeat again?
Okay, so what happens to the molecules? So these are called as molecules, right? What happens to the molecules when we heat them? Okay, when it becomes hot, what happens to the molecules inside the liquid?
Expand.
Yes, it expands and it allows them to have a greater freedom.
Freedom to move.
Yes, it will have a greater freedom to move. You can see the spaces inside, right? Okay.
Yes.
Okay, very good, Kankavi. Do you guys understand, on-site students? Do you understand? Do you understand? Okay. Now let's look at equilibrium, thermal equilibrium and heat flow. Okay, so these two topics. So first, let's look at heat flow. Remember this, okay? Heat always flows from hotter, okay, hotter objects or hotter places to a cooler object or a places. Remember that, okay? Heat always flows from hotter object or places to a cooler object or places. This is called as heat flow. So heat flows from, yes. Heat flows from, does it flows from hotter object to cooler object, or does it flows from cooler object to hotter objects? You can go to washroom and come back. Go washroom and come back. Go to washroom and come back, okay? Because I understand as well, there's no air here, right? You can go to washroom. Yes. It's hot here. Okay, so heat flows from, yes, girls. What about you? Heat flows from, does it flows from hot to cold or cold to hot? Hot to, yes, hot to cold objects, okay? Heat flows from hotter objects or places to a cooler objects or places. So, for example, let's say this example, okay? The kettle, there are boiling water inside the kettle, okay? So, let's say the boy or someone places his hands on the kettle. So, what happens? The heat transferred from the kettle to our hand, right? The boys take his hand away from the kettle because the boy feel the heat of the kettle. So here, the heat is being transferred from the kettle. Since kettle is hot, right? It's being transferred from the kettle to our hand. Why? Why is it transferred to our hand? Because our hand is cooler than the kettle here. Understand? Since kettle is hot, it is transferring heat to our hands. Okay? Second example is the ice melts when the boy, okay? The ice melts when it is in the boy's hand. The boy's hand is cooled now. So the heat is transferred from what to what? From the boy's hand to, okay, online students, go home.
Yes.
So here, the heat is transferred from what to what? In this picture. When we put an ice in our hand, the ice tends to melt, right? So is it being transferred from, what is it being transferred from?
Liquid to solid.
No. Okay, Kahom, here, okay? So the heat is being transferred from our hand to the ice cube here. Okay, that's why the ice cube is melting, right? Understand, everyone? Next one is thermal equilibrium. Okay, thermal equilibrium. So thermal equilibrium is a state of a system in which all parts are at the same temperature. So the word thermal, can you see this word thermal? Thermal means temperature. Okay, word thermal means temperature. And the word equilibrium means having same temperature. Okay, is known as equilibrium. A state of a system in which all parts are at the same temperature is called as thermal equilibrium. Understand, everyone? The state of a system in which all parts have a same temperature is called as thermal equilibrium. So for example, this is a warmer object and this is a cooler object. So heat transferred from, is it transferred from warmer object to cooler object or cooler object to a warmer object? Panya.
Yes.
Okay, so is the heat transferred from warmer object to cooler object or cooler object to warmer object?
Warmer object to cooler object.
Okay, very good, Panya. So the heat is transferred. Very good. The heat is transferred from a warmer object to a cooler object. Always warmer to cooler. Okay. So when the heat is transferred from a warmer to cooler object here, right? The warmer object tends to give out the heat until this cooler object becomes the same temperature. Okay. When these both become same temperature, we call it thermal equilibrium. Understood? Understand, everyone? Okay, let me ask someone. Okay, very good, Panya. Let me ask this to someone. Is this cooler object or warmer object? On-site students, you. Is this cooler object or warmer object? It says 0 degrees Celsius. Is it warmer object or cooler object? Yes, it's a cooler object. What about this one? Yes, this one, 100 degrees Celsius is hot, right? So it's warmer. 0 degrees Celsius is very cold, right? So we said cooler object. So this warmer object, it tends to give heat to the cooler object until it becomes same temperature. You can see 50 degrees Celsius and 50 degrees Celsius, right? Both have same temperature. So we call it thermal equilibrium. Understood? Understood? Okay, same temperature, thermal equilibrium. Okay, how heat is transferred? So heat are transferred in 3 different ways. Can someone read? Yes, can you read this 3? Yes. Can you please read this? Yes, very good. Conduction. Conviction, very good. Louder. Last one. Radiation. Okay, please, all the students on site, please read it with teacher louder, okay? Because I don't want you guys to feel sleepy. First one. Once more. Second one. Louder. And the last one. Okay, very good. Okay, you in the front guy. Tay, can you please read this 3? What is this first one? Conduction. Okay, conviction. Radiation. Okay, so these are the 3 ways that heat is transferred. Okay, so let's look at, okay, I want online students to read as well. Where is Pokpong? Pokpong gone? Okay, Pokpong. This 3. What is this?
Conduction,
Very good.
convection,
Very good.
radiation.
Okay, excellent. Pokpong. Okay, so conduction, convection, and radiation are the 3 ways to transfer the heat. Okay, so let's first look at conduction. Conduction is the flow of heat energy through what? Solids, okay, such as metal. So metal is a solid object, right? Conduction is a flow of heat energy through solids such as metal is called as conduction. Understand? Okay, let's look at the example of conduction. So remember, conduction is heat that transferred from a solid object. Okay, transferred to a solid object is called as conduction. So let's look at this example. Heat from a hot coffee makes the cup itself hot. So the heat is transferred to which one here? Okay, online, on-site students. So the heat from this coffee is transferred to what? Girls, the heat is transferred to what here? The hot coffee, right? The hot coffee. The heat from the hot coffee is transferred to what? To the, what do we call this? To the cup, right? This is a cup, right? The heat from the liquid from the coffee is transferred to the coffee cup here. Okay. Second one, the metal spoon become hot from a boiling water inside the cup. So here, the heat is transferred from the hot water to the heat from the water is transferred to what? What do you call this? Online, on-site students, what do you call this? Spoon. Okay. The heat is transferred from the hot coffee to the cup here. And the heat is transferred from the liquid, the hot water to the spoon here is known as conduction. Understand? Okay, let me ask one more here. Mutta, can you please turn on your microphone, Mutta? Hello, Mutta. Hello, Mutta. Okay, let me ask this to Panya.
Yes.
Okay, very good, Panya. So the heat from the hot coffee is transferred to what? To the cup here, right? Okay, very good, Panya. So the hot coffee, right? The heat from the hot coffee is transferred to the cup here. So it's known as conduction. All right, everyone. So we're running out of time. Okay. Second one is convection. Convection is movement of the transfer of heat within the fluids. And here is called as convection. Okay. The movement of the transfer of heat within the liquids. This is a liquid, right? Or the gas is called as convection. Conduction is transferring from heat through solid. Is called as conduction. Now, convection is movement of the transfer of heat within, inside the liquid only, is called as convection. Okay. So some of the examples here are the air movement in home. So air flows in our room as well. The hot air tends to move up and the cold air tends to move down. Okay, so this is the example. Another example is the boiling water here on the stove, right? So the cold water, the currents inside the cold water also tends to move down, okay, when it's heated, whereas the hotter water tends to move up. So this is convection. Okay? Understand? Understand on-site students? All right. Last one is radiation. Radiation is, okay, the process where the heat travels through empty space or vacuum is called as radiation. Empty space or vacuum means same meaning, okay? Vacuum and empty space are the same meaning. So the process of heat energy travel through an empty space is known as radiation. Understood? So here the heat is being radiated from the fire, right? To our hands here. It's traveling from an empty space to our hands here, right? So this is the example of radiation. Understand, on-site students? All right, online students, do you understand?
Yes.
Okay. The word vacuum means empty space. Okay, so in radiation, the heat travels through empty space. It's called as radiation. Okay, convection, the heat travels through solid, is called as conduction. Convection, the heat travels through the currents in liquid and in the air, is called as convection. So we have about 6 minutes. We have to be faster here. So last one is keeping building warm. Okay, so heat flow inside the building as well is very important. Okay, to make ourselves comfortable, to let the air flow. Okay, heat flow inside the building is very important for the occupants. Occupants mean people who are living inside the room is called as occupants, to feel comfortable. So in order to let the heat flow from inside the house to outside, we need to have a good ventilation system. So the word ventilation means a system or means of providing a fresh air is called as ventilation. Okay, so let's look at the ventilation system in traditional houses. So the ventilation system in traditional houses, they are built with ventilation holes. Okay, they are either built on the base of the house or you can find it at the top near the roof, the ventilation holes. Whereas in the modern houses, we can see it like this, okay, the exhaust fans. The ventilation system is more effectively installed by exhaust fan and extractor. And the final one, in the modern houses, We are equipped with fans and air conditioners, right? To let the house flow, to let the heat flow. All right. So why do you think we place this, okay, this air conditioner at the top? It's because inside the room, the heat, the cooler heat will be down here, right? Whereas the hotter heat will always be up here. So we keep this conditioner, air conditioner on top of the wall because to first let the heat, right? The hot air to move out and cooler air to come in. That's why we keep the air conditioner up on the walls. Understand, everyone? So with this, we are done with reviewing the topics for this chapter, okay? So I want every one of you to turn to this page. Online student, please turn to page number 81. Do you have your books? No, right? Okay, make sure you write everything. I'm going to check it on Friday, okay? So this one is conviction. So what do you think this one will be? Oopsie. So let's look at the first one. This is vacuum, okay, vacuum. And this one is going to be liquid. Hold on. So the first one is solid. Second one can be the liquid or gases, okay, which is called as convection. And last one is radiation. So please write these answers, okay? Because since we are running out of time, I want you guys to write this down. So from the solid, conduction is through the solid, right? Convection, the heat passes from gas and liquid. And from the radiation is through empty space. It's called as radiation. And I want you guys to write this one as well. So the volume of the
Teacher update.
page number 81. 81. So what happens to the volume? When we add heat, it tends to expand, right? So we call it expansion. Heat loss causes contraction. So please write these answers down, okay? We are running out of time. So for the temperature and for this one, we need to write it. Only write it up until here. Online students, please write it down. We only have 2 minutes. Remember, okay? Expansion means increase in size, okay? Increase in size. Whereas the word contraction means decrease in size when the objects are cooled down, okay? In the conduction, the heat is passed through solids. In the convection, the heat is passed through gas and liquid. In the radiation, it's passed through vacuum. Vacuum means empty space, okay? Remember that. We have 1 minute. On-site students, write it down. You can write it down. Feeling sleepy, write it down, fast. Okay, so we have less than 1 minute. So online students, if you are done with this one, please take a picture of your work and send it in the line group, and you may leave the Zoom classroom. I will see you guys on Friday again. On-site students as well, make sure you write this down, okay? Okay, and I will check your book. Can you all bring it tomorrow, your book? Can you bring it tomorrow? And then keep it at the back there, okay? On the table, I will check it and then return to you back again, okay? Do you guys have any question? So on Friday, we will start with new chapter. Okay.